Carbon is essential to life. This important element is found wherever life crops up, from the tundras of the Arctic to the depths of the ocean. Carbon and various nutrients are distributed in a cycle across the globe. Let's examine the carbon cycle by following some carbon through a marine food chain and watching its journey through the sea. We now find ourselves near the surface of the open ocean on a beautiful sunny day. Let's look at some carbon. This molecule of carbon dioxide has just dissolved into the water. Who is this? This green fellow is a phytoplankton. We can call him Philip. Philip the phytoplankton is similar to a plant, taking in our dissolved carbon dioxide and using it for photosynthesis. Our carbon is used by the phytoplankton along with water and sunlight to create oxygen, along with the simple carbohydrate known as glucose. Glucose is used in a process called respiration, which in the simplest terms is the opposite of photosynthesis. Respiration turns glucose into energy that the organism can use with the byproduct of carbon dioxide. Many other carbons from carbon dioxide are used this way throughout Philip's life, getting used for making a multitude of carbon-based products, even eventually getting used in respiration. Because Philip makes the energy he needs on his own without needing to eat other organisms, we call him an autotroph, or a producer. Autotrophs are often at the bottom of the food web, being eaten by other organisms, which are classified as heterotrophs or consumers. It is time for phytoplankton Philip to share his bounty, as this krill has just spotted a tasty snack, our green friend Philip. The carbon, energy, and nutrients contained within our phytoplankton now have the opportunity to be used by this krill. We now follow Krillium, the krill, throughout his life using carbohydrates for energy, respiring carbon dioxide, and floating around as krill and other planktonic organisms do. Although Krillium here does eat other organisms, he is nowhere near our last stop on this journey through the food web. Krillium has avoided being eaten by a multitude of small fish and other predators, but it is once again time to switch our focus. This is Willa, a blue whale. She loves eating krill. Willa eats up to 16 tons of krill per day, and Krillium is not escaping this mouth. Willa is a heterotroph like Krillium, but since she eats other heterotrophs, she can be on the third or even the fourth trophic level. Willa the whale uses this large amount of krill to sustain the large amount of energy she needs to keep living each day. Only around 10% of the energy used by an organism is transferred to the next trophic level, so predators like Willa need to eat a lot of food to get their energy. She uses the energy from carbohydrates and other products to keep swimming and eating krill. Willa leads a peaceful life, swimming, eating, singing, and creating giant misty plumes of carbon dioxide when she exhales. Although Willa is very large and has few predators, life still catches up to us all, and Willa's time will soon be up. Willa is able to make a final impact on this world, as when she falls to the bottom of the sea, she takes all of the nutrients and energy she had left with her when she passed. She is now the basis for a deep-sea ecosystem called a whale fall. As you can see, Willa's body provides a massive food source for many organisms here in the deep sea, such as octopi, worms, and even some deep-sea fish like the grenadier fish. These creatures are scavengers and decomposers. They tend to eat from any trophic level as long as it's already dead. Our carbon friend has just been taken in by one of the worms, a decomposer, who is doing a lovely job recycling nutrients, energy, and carbon, and making them ready to be used by others. The carbon in the carbohydrate eaten by the worm is getting used up and now has been discarded from the animal altogether through respiration. Our carbon is now back to being a dissolved carbon dioxide molecule, but this time it's deep in the ocean. This video only represents one small part of a larger cycle in one ecosystem of the many in the world. These large cycles that nutrients and carbon go through do a great job at showing how connected our planet is. Many indigenous cultures understand this connection and have understood it for thousands of years. This intersection of indigenous knowledge and more Western or European notions of scientific study reminds me of the Mi'kmaq concept of etuaptmunk, or two-eyed seeing. Essentially, two-eyed seeing is using the perspectives, strengths, and ways of knowledge of two distinct cultures to benefit everyone involved. After years of floating along in the currents, being used and respired, and seeing other carbons within the marine sediment, our carbon is back near the surface. There's a chance it could end up in the atmosphere, but with this new friendly green face approaching, it's a safe bet that our carbon will be in this marine environment for a while longer.